And this is pre-calculus, chapter 2 notes. This is 2.1 and 2.2 combined. So the vertex form of a quadratic function is in the form f of x equals a times x minus h squared plus k. Your vertex here is going to be hk, and your axis x equals h. Standard form of a quadratic is f of x equals ax squared plus bx plus c. Your axis of symmetry, so that's your x, it equals negative b over 2a. To find your y of your vertex, okay, so your x above is your x of your vertex, and to find your y, you just plug the x back in. And then your pattern on a parabola or quadratic is always 1a over 1, 3a over 1, 5a over 1. And the y-intercept is always c. You can tell whether this opens up or down if a is positive or negative. So if a is positive, it opens up, and a is negative, it opens down. So let's take a look at an example. So here we have f of x equals 2x squared plus 8x plus 7. So does it open up or down? Our a value here is a positive 2, which means it opens up. Our axis of symmetry is going to be that x equals negative b over 2a. Okay, so our b value is 8, so it's going to be negative 8 over 2 times 2, which is negative 8 over 4, which is negative 2. So our x value is negative 2, so that's our axis of symmetry. Okay, because remember that with a quadratic or a parabola, right, it's a mirror image of each other. So in this parabola, at x equals 2 is where it's going to be a mirror image. I know my picture is not very pretty, but mirror image. So to find the vertex, we're going to plug this x value back in. So it's going to be 2 times negative 2 squared plus 8 times negative 2 plus 7. So that's going to be negative 2 squared is 4 times 2 is 8. Remember, you always do the squared first. Minus 16 plus 7. So that's going to be 15 minus 16, which is negative 1. So I just added the 8 and 7 to get to 15. So my vertex then is negative 2, negative 1. So that is where this parabola is going to start. Okay. So find the y-intercept. The y-intercept is always just this value right here. So that's going to be 0, 7. Our pattern is 1a over 1, 3a over 1. So 1 times a over 1, which is 2 over 1. 3 times a over 1, which is 6 over 1. 5 times a over 1, which would be 10 over 1. When we're graphing that, we started our vertex. So from here, we're going to go up 2, out 1 on either side. For this next one, we're going to start here, okay, at the point we just graphed, not at our vertex. We're going to start at these 2 points, and we're going to go up 6, 1, 2, 3, 4, 5, 6, out 1 on either sides, and you should hit this y-intercept at some point. And really, we can't do the 10 because we're going to go off the graph. Okay, and now that is graph. So let's take a look at intercept form of a quadratic function. So intercept form is in the form where it crosses the x-intercept. So here you have a times x minus r1 times x minus r2, where r1, 0, and r2, 0 are your x-intercepts. Okay, x-intercepts, that's where it crosses the x-axis. The axis of symmetry is just r1 plus r2 divided by 2. So remember, it's just an average of the two, right? So if your R1 and R2 are here, okay, then you're going to add those two together and divide by 2 to get the middle. Okay, we're looking for the average. Okay, and then your vertex. Okay, once you know your axis of symmetry, you'll plug it back in and solve. Or the other way you can do this is you can multiply these out, multiply your a through, and then you'll wind up with a standard form, and then you can use this method. This one you won't see a whole lot. We don't use it a whole lot, but since it's an apex, that's why we have it for you. So it says convert to standard form. So I'm going to show you how to do that first. So the first thing we're going to do is FOIL. So first, outer, inner, and last times that -2, and combine our like terms. And then we're going to multiply that -2 through. So -2x squared. And then we are going to do minus, let's see, help me out here. 8 times -2 minus 16x plus 18. So that is now in standard form. Convert it to vertex form. Okay. So now we're going to complete the square to convert this to vertex form, or we can actually just find our x and our y value. Okay. So the very first thing I'm going to do here is I'm just going to leave this -2 out here, and I'm going to find that x and that y value. Okay. So I'm going to go back to this equation right here. Okay. And I'm going to find my x. X equals -b over 2a equals -8 over 2 equals -4. So that's x plus 4 squared. And now I got to plug my y back in. So it's going to be what did I do here? Somehow, hold on. Somehow I got that. Perfect. 2 times a, perfect. Okay, so, and that should be +4. I pulled that -2 is still out. Yes, okay. So this should be a +4. And the other way you could do that is by adding these together. So -1 plus 9 equals 8 divided by 2 would give you a 4. Okay. And then we're going to plug that y value of 4 back in. So we're going to get -2 times 4 squared plus 8 times 4 minus 9. And see if I can do the math. 16 plus 32 minus 9. 32, 16 minus 9. And looks like you get -78. So that would be a -78 there. Okay. Assuming I did my math right. 16, 32, -9, -2 times that. Okay, so that looks right. All right, so that would be written in vertex form. Okay. And we're going to learn how to complete the square later, and that's going to make it a whole lot easier to do. Guys, we're not going to have you doing a whole bunch of this where you have to convert. Okay, these two are the ones you're going to need to convert between. Okay, let's take a look at a sample problem here. So it says a ball is hit at an initial height of 3 feet above the ground at a velocity of 100 feet per second and an angle 45 degrees with respect to the ground level, or the level ground. The path of the ball is given by this. So it gives us a function, and it says, what's the maximum height of the ball? Okay, well, there's one thing we didn't talk about when we were talking about parabolas. So if we have a parabola that's shaped this way, it's going to have a maximum. So if it's going down, it's going to have a maximum, and that maximum is your y value of your vertex. If it's going this way, then it's going to have a minimum, okay, the lowest value it's going to reach, and that minimum is your y value of your vertex. So this one right here, all we have to do is find the y value, okay? So we're going to do x equals negative b over 2a. Since we negative 1 over 2 times negative 0.0032, which is going to be negative 1 divided by 2 times negative 0.0032 equals 156. So it's approximately 156.25. Okay, that's our x value, but now we need our y value, okay, because we want the maximum height of the ball. So now we're going to say negative 0.0032, 156.25 squared plus 156.25 plus 3. And now I'm just plugging it in. Okay. 156.25 squared times negative 0.0032 plus 156.25 plus 3 equals 81. So f of x is approximately 81 feet high. Okay. So not too terrible. The next one is the same type of problem. It says the percent that people will donate to charity is related to their income. So it's related to their income, and it's between 5 and 100. Okay, so X is between 5 and 100. So that's the income in thousands of dollars. So we're saying, you know, anything less than 5 or anything greater than $100,000 of income is minute enough that it's not included in this representation. So what income level corresponds with the minimum percent of charitable contributions? So if you'll notice, this parabola is shaped this way. So a minimum is going to be down here, and that's going to be our y value. Okay, so we're looking for our y value again. Okay, and and actually it says what income level corresponds. So actually we're looking for our x value to find to see just what the income level is. So now we're going to say x equals negative b over 2a equals positive 0.1529 over 2 times 0.0014. 0.1529 divided by 2 times 0.0014. And that's going to be 54.6 thousands of dollars. So people who make $54.6 thousand a year are the lowest contributors to charity. Okay? And that's just based on this relationship here.